So I said I'm a backend developer. I work here in Nigeria. I primarily use Node.js as one of my stacks, even though sometimes I branch out. The problem I'm trying to solve is the same. So any stack goes. Yeah, so the essence of today's class is to give development is okay. One of the targets is to get you all to adapt the mindset of a backend developer, right? So before you get into anything, you first of all have to soak yourself into the mindset that could get you to actually doing that thing. That's the essence of today's class. Also, what backend is, how you can think like a backend engineer, and how you can get ahead. Right. So, yeah. So backend engineering fundamentals. This is what we'll be looking at today. Fundamental pieces of backend engineering, software engineering from backend engineer's perspective, and what an API is. Right. So I like to think these are pieces around backend engineering. If you have a basic grasp of this journey towards becoming a backend engineer, it'll be smoother. It's my classes with an analogy, right, to get everybody just um, give you a background feel as to what I want to talk about. So this is an analogy. I like to start my classes with an analogy. Everything that a backend developer does or a backend engineer does starts with the server. Right? And a dense concept to understand. It just basically means your computer. But before we go into that, just read the content of the screen. Imagine you walk into a restaurant and place an order with a waiter. You, as the client, you're the person making the order, and then the waiter is the person who goes to get that order out. Now, the server is your kitchen, okay? So that's just the background framework, right? That's something I want you to keep in mind. Now, so a server, how I want you to think of a server is like a kitchen. It's like um, what goes on. So if you go in place an order, you don't get to see what happens behind the scenes, right? You don't get to see what goes on in the kitchen, right? All your concern is on to you. Right now, of course, if the order in place, what gets returned to you does not match what you placed, you would always reject it, right? Is the front end. Okay. So I remember the first session you had, um, I don't know if you all joined it, but the first session was about front end development. And we learned about, okay. Now, the front end is basically the client, all right? Or most of the time, it's the client. However, it would also have a server as a client. We'll go into that much later, all right? But for now, just let that stick that the client is the person or the computer making the request to the server. Now it takes it to the server. So um, the that's for now. That's just the perspective I want you to have. Okay. So a server is a computer with networking capabilities and ability to store and process data. Remember, I said that a computer is a server. Okay. So a computer most computers have networking capabilities and they have the ability to store and process data, right? So if you have a computer that doesn't have any of it, not a server, right? So every server, all right, or every computer should have these capabilities. I can't think of anyone that doesn't have this. That's the idea. So a server that has networking capabilities and ability to store data is what you term as a server. All right. So back to this again. I want you to have that picture in your mind. You go on type google.com. All right. That interface where you type google.com and wait till the point where you eventually get to the page, the web page, and you start scrolling and you start, accessing the information you want. Um, that page is client, all right? But then what goes on behind the scenes? What takes your request to the server that holds that data? It's the API, all right? The server is what contains the information you are looking for. Does that make sense? Okay. All right. So the server, right, is what is responsible for, holding that data that you get to see when you make the request to it. So just like it's the food given to you, that's the same thing. When you're on the computer, most of the time you make a request to the server, all right, and then the server holds that data and then returns it back to you. Um, that's just basically what a server is. All right. Now, a client had already joined that request services for resources from a server. So in backend development, the client is what interacts with the backend server to fetch data, send information, or trigger action. So, like I said, all right, a client is not necessarily tied to just the browser, right? A computer. It could be another computer, another server talking to the backend server in quotes. Yeah. So you could have one computer act as a server and then try to access resources from that computer or from the server. The client, in simple terms, is just any device or application that requests services or resources from server. Okay, is that clear to everybody?
Yes, to me. And Harrison to say yes.
All right. All right. Moving on. Now, so we have a front end applications. We have Chrome, Firefox, Safari. We have mobile apps. So a banking app communicates with the backend server to fetch your account balance. So of course, some of you use banking apps to send money and receive money, right? Sorry, to send money or to, all of those client apps, they are clients, all right, that give you the interface to communicate with the server. So there's always a server that holds the resources you're looking for. By making Zoom, you need the clients to consume them, right? You need an interface to consume those resources. Okay, so the other ones, desktop applications, all right. So there is a Zoom server that enables this call to go, that enables whatever interaction we are having here to happen. Okay, and then like I tried explaining, backend services. So you could have two servers communicate. One might act as a client when requesting data from another server. Does that make sense? Is that clear to everybody? Yep. The, Now, before we continue, I'd like to make this very clear. Networking. Easy without networking, right? So, like I said at the beginning, that servers are more like computers, right? So, right, that computer is meaningless to you if or that computer is meaningless to the idea of backend engineering. It doesn't have networking capabilities. Okay, so if you have a server and that server has no networking capabilities, that computer cannot be a server. Okay, so I just had to put that down. So networking plays a crucial role in backend development, allowing communication between clients and servers. And so this is the next slide. Network adapters. Now I did this. I took this picture somewhere just to paint an illustration. So for most computers that have networking capabilities, you often see this by way of a router, all right, or over Bluetooth. I don't know if there are some of us who have used Bluetooth before to connect two devices and send information. Are there people here who have used that? Are there people who have used that? I like to,
Use routers or use switches.
yeah, the router switches, but Bluetooth. Let's take it back to the very beginning, right? When these were not mainstream. Are there people who used to use Bluetooth? I like to see. Okay. All right. So yes, that counts as well. All right. So um that's also one of the networking features, right? So you have two devices communicate, right? So as the Wi-Fi and the switches, right? So you can have any of these. At my office, I do this very well. When the front end and the back end, we're trying to test, we're building a feature, and the front end developer is present at the office. What we like to do is connect. So my computer, I would mount it as a server and provide the IP address for the front end to communicate to it. And once we are connected over the office network, we are able. That's the idea. And just in case you're wondering, right? Let me show you the part of mine. So I use a Linux machine. I don't know about you, but I think on Windows the command should not. Can you see my screen?
Yes, we can. We can see your screen.
Yeah. So if you do if config, right, you should see all of these. This is the one that interests me. This is the WLPSO. All right. So here, this is the IP4 address. I'm going to explain what that means in a bit. But then this is the IP4 address. So if I give this to you and I'm using right now, and I give this to you, all right, and then I spin up a server, you can connect to me, connect my device, and access resources, all right, on my computer for local host. All right. So this just means that if I spin up a server on my computer and try to access that server, all right, or try to access a resource that lives on the server with my computer, this is the IP address I would use. I'm going to explain that very soon. All right. But on Windows, I'd like you to just think out with this. Just I think on Windows, the command, if you open your CMD prompt and do IP config, you should see something similar to this. Okay. One of these, either of these stands for Bluetooth. So that's just the basic idea. Yeah. So now networking layers, kids, right? There are layers that it needs to go through. All right. So before this, now by communicating, right? When two people are communicating, what are they actually sending? What are they doing? What does communication? Let's bring it back to the very big in this class. Yeah. So if two people are communicating, right, what are they actually doing? Uh, I'm happy that the class, we are not much in the class, so we can actually have um, brief commentary. If I murdered your name, Lade, and the rest. So I'll start with you, Lade. If two people are communicating, yeah, what are they actually doing? All right, I like to get your view, so we build from there. Lade,
Yes, two people are communicating. Network?
yeah, can you hear me?
Yes, I can hear you.
Yeah, did you hear my question?
I didn't hear your question, sorry.
Yeah, so I'm saying that if two people are communicating, what are they actually doing? What goes on between? Since how can you describe communication? Because I've been saying communication, communication, communication. So I like to get I like to put your brains on what you think communication is, and let's tie it back to humans. So if two people are communicating, what does it mean? What is the crucial thing that goes on when two people are communicating?
They're sending messages to each other.
Fantastic. Yeah, does everybody agree with her?
Yeah, that's
Yes, yes. So good. Now they are actually sending messages to each other. Now your computer, right, also sends messages. However, it doesn't send a message in a way that you would understand. I don't know if you've heard this thing that the computer only understands zeros and ones. Uh, this signify. Has anybody heard that before? That the computer only understands binary, only understands zeros and ones. Am I still in the box? Yeah. Okay. So Harrison says yes. Okay. So yes, the computer only understands zeros and ones. That's the language that it speaks. Okay. So at the first instance, when two computers are communicating, right? The data is sent first at the physical layer. Okay, so you have data leave a computer from leave one computer to another, it mostly happens over the Wi-Fi, over an Ethernet, or over a Wi-Fi on Ethernet, all right? And one of the things that's crucial at that level is the MAC address of the device. So every device, all right, has a MAC address. Now that address is unique to that computer or unique to that device. So your phone has a unique MAC address, your computer, your laptop, your PC has a unique MAC address. Okay. So that address is unique to your computer. Now, if you pick up any, okay, I think that's clear enough. So every computer has a MAC address. Now, moving on the networking layer. Now, yes, there are 6 layers. I just carefully picked this out because these are the ones that pertain to you as the backend. If you have no business understanding what happens at the lower level. Of course, you may want to do it for fun, right? So, but as it pertains to backend development for us or backend engineering, right? This is the part that concerns you. All right. So networking layer. At the networking layer, you have IP addresses. Okay. So the IP address, like I showed you here, can everybody see my screen?
Yes.
Can you see my screen?
Yes, we can.
Yeah. So this is an IP, my IP address as we speak now. Okay. And if I want to have any device communicate with mine, for now, that device has to be connected over the network, has to be connected to my network, the network I'm using now, to be able to speak to me with this IP address. Okay. But the point I'm trying to make is this, that every computer on the network has an IP address. So as a backend developer who is concerned about building applications, yeah, this is you need to really be aware of an IP address. Okay, you'll be working with this very, very much. Okay, now the IP address this time is unlike the MAC address. The IP address is still a unique address uh, that binds your computer and gives your computer an identity on the internet. Now, I know many of us we use the word internet, but we don't really think of it in terms of what it really is. So, given all I have said, I've said that a backend, a server is a computer. Does anybody dispute the fact that um, your computer, the computer you're using for this meeting, cannot be a server? Does anybody dispute that fact? Or I wish I could open a poll here so everybody would vote. Does everybody agree with the fact that your computer is a server? So your computer, I can connect to your computer from where I'm seated. Does anybody think otherwise?
Yes, you can. Possible to connect to my computer.
Fantastic, of course, yes. So even this call is the IP, your IP address is what facilitates this call. Okay, so now the internet basically is computers coming together. All right, so I have the Google servers, the Google computers that live somewhere in Washington DC. I don't know where it is, and my computer talking to each other, right? So I also have another computer, let's say Facebook, right, living wherever it is, and my computer talking to it over the IP address. Okay. Now, if you want to know the IP address, now another thing to point out is the IP address looks somewhat like this. I had said I was going to explain what IP4 and IP6 address is. So on my computer, you can see this. All right, you can see iNet. All right, IP4. This is the IP4 address, and this is the IP6 address. Okay. Now, remember I said an IP address is the unique identity of a computer on the internet. This gives my if this were to be my IP address on the internet, because as it stands now, this is not my IP address on the internet. It's just the IP address that my network provider assigns to me. All right. But the IP address of any computer on the internet looks somewhat like this. Okay, so if this were to be my IP address on the internet, it means I could talk to your computer or any device could talk to my computer, right, using this. Okay, now, if you notice, right, just after every dot, okay, how many dots can you see? How many dots can we all see? 1, 2, 3. Okay, the numbers after every dot, right? Can we count how many it is? We have the first one, 192. We have the second, we have the third, and the fourth. Does everybody agree with that?
Yep.
Yep.
Right. Right. Now, that's why it's called IP4. Now, the idea behind this is that, so remember I had said the computer only understands.
Hi, Ezekiel. I think we lost your voice. Okay. I think this is a connection issue. Or can any other person hear Ezekiel?
No, no.
No.
Oh,
Stop sharing his screen.
okay.
Yeah.
I think that's a connection issue. So before he comes up, I'll just try to bring your attention to what patients posted on the meeting chat. Before Ezekiel comes back, we normally take attendance for every sessions. If you're coming back for this session, this is not your first time, you're already aware of that. So there's always an attendance for every session. The form, it's always a form. You just fill it. It's very, very simple. The form to mark your attendance is on the meeting chats. Thank you very much. Hi, Ezekiel, are you back?
Yes.
Oh, okay, cool.
All right. Please, I'd like to know where I left off.
Not very long. You were talking about the IPv4. I'm explaining okay, IPv4 now because the numbers of the subset is 4, so that's why it's called IP4.
Okay, right. I'm glad I still have everybody. All right, so I was explaining that this 8 bits represents 1 byte. All of these, right, represents the bits on each unit.
Stop sharing.
Oh, sorry. Can you see my screen now?
Yes, just if you present. Okay.
Fantastic. All right. So each of these represents the bit. All right. Now the idea is that between 0 and 255, all right, your computer should be represented. All right. So now looking at this, we have 192. This falls within the range of 0 to 255. Okay. And this represents one chunk of the 32 bits, all right, that IP4 addresses represent. And now you see 168, right? This falls within the range of 0 to 255. Now, the reason behind this is what I want you to take home between IP4 and IP6. Now, you see, if you think about these numbers in its entirety from 0 up until 255, every year, new computers are being produced, all right? Now, imagine all devices are connected to the internet, and each of them have an IP address. And we are using the IP4 system where we have 32 bits. So we have computers within the range of 0 to, or computers take up these numbers within the range of 0 to 255. We are roughly 8 billion people on the planet as we speak. If all of us are to if all of us have computers and we are to connect to the internet, you find that we would exhaust all of these numbers. All right. Or does anybody think otherwise? I like to hear.
Nope. Because I know
Right.
that one person can even have multiple IPs.
Fine. Fantastic. Yeah. So we would all exhaust these numbers. Okay. So from yes, would all exhaust these numbers. There's no better way to put it because the essence of IP6, all right, the reason why they came up with IP6, right, is to give us a bigger bandwidth. So now we have more IP addresses to go around all computers in the world. So IP6, I think it's 128 bits. Each of these represents, so if you divide, I think how many chunks does it have? 1, 2, 3, 4, 5, 6. Each of them sums up to 128 bits. That way, we have more bandwidth. We have more numbers to play around with. So, of course, as you can imagine, each of these would take, every computer that's connected to the internet will take one of these numbers, and it's all down to probability. All right. So if you want to check the IP address of a computer as we speak, if you do this, you can always find it. If if you want to find the IP address of your computer, or know the IP address of your computer, you can, I think I should even leave that to you, but I have an exercise here I have something to show everybody. Now, on Google, right? If I want to know the IP address of Google, okay, let's see. If I want to know the IP address of Google, can you all see my screen?
Yes.
Okay. For those of you who use Linux or Mac, I think you should have this ns lookup command. Okay. Now, if I want to know the IP address of any website, all right, I can easily do this and I'll find that IP address. Now, as you can see here, what we have is 216.582.223.228. Remember, I had said that every device, every IP4 address has these numbers, all right? And none of them should exceed 255, okay? So randomly, all right, when Google decided to take their resources to the internet, they were given this IP address, all right, as their IP4 address. And this also represents their IP6. Now, for most servers that you find, all right, when you build your application as a backend developer, your application will have an IP address. Okay, that IP address represents your computer on the internet. Okay, and that IP address is also unique to your computer. Every resource you try to access on the internet is hosted on the server. And those resources or that server has an IP address, a unique imprint or a unique identity assigned to that server. Okay, so this is Google's own. And guess what? Now, if I take this IP address and come here, open a new tab and paste it, right? This should take me to Google. Okay, so this is just it's just the same as me saying www.google.com. Okay, by just identifying the IP address, I can take that IP address, visit the internet with it, and still access the same resources. Okay, I'm going to try the same thing. How many of you know GitHub?
Obviously. Yeah.
Okay, so I'm going to go to GitHub.
Hi.
Okay. So let's find the IP address of GitHub. So this should take a while to load up. Internet connection is bad. Okay, I think they gave it to me. Oh no, that's not it. Okay, so they chose not to give me the IP6 address, but I have the IP4 address. So you can see 140.82.121.3. And of course, again, none of these exceeds 255, which is the highest, and 0, which is like the lowest. So if I take this IP address and I use it to visit the internet, I should still be taken to GitHub's page, right? So now, since I'm using the IP address, I will not be allowed to do that. GitHub has something that blocks people trying to visit the site with the raw IP address, but of course I can bypass it. So if I proceed, I'm still taken to GitHub's page. So this still feels like typing www.github.com. Okay. Is it clear to everybody what IP addresses do and how they function?
Yes.
Does anybody have a question?
I do actually. For context,
Okay.
now that we can do that for web-facing platform or web-facing applications, I saw your IP address. Can I copy it and search for you up like that?
Now, the IP address that you have here, right, you cannot use it because this IP address is assigned to me by virtue of the network I'm connected to. So if I put this on a server, if my laptop were a server, there are some configurations that I would have to make, all right, to expose an IP address that you can copy and try to visit, all right? So now, yes, the IP address still works. If you are here with me in this workspace and you're connected to the same network that I am using to do this broadcast, yes, you'll be able to connect to my computer. All right? Does that answer your question?
Yeah, it does.
All right. Yeah, you can guys, you can play with this, all right, at your spare time. Okay, you can check the IP addresses of many of the applications that you like to use, right? You can check their IP address, and there are actually people, those people who used to code, who started coding back in the day, right? Many of them they still like to use the IP addresses to visit websites. So for sites that have been long-standing since 1970, then when the domain name thing didn't come into limelight, right? Then it was IP addresses all the way. So if you wanted to visit someone's address or somebody's server, you would need to type or know the IP address and use that to visit the computer or visit the server. I personally have used the TCP. I use the TCP layer very often when I'm building my applications, and then it's not because TCP is better than UDP or UDP is better than TCP. It's just the fact that the problems I solve with my backend development, or the problems that come to me most often, are centered around TCP. So that explains why I use it the most. But just to explain what they mean, the concept I want you to have about both of them. So TCP, the way it works is that, yes, you have your client, you have your server, right? Every data that is transferred between the client and the server, every bit, all right, every piece of data from the biggest up until the smallest bit has to be transferred. So if I make a request, right, to a server, all right, to a TCP, sorry, if I make a request over the TCP layer, all right, to the server to send data to it, every bit of data has to be transferred. All right. That's just how I want you to think about it. UDP is quite different. So UDP does not enforce those rules. So between server and client, the data does not have to be transferred. Not every piece of it can be transferred. So this is the example I like to give you. On this live stream, I know, yes, this is going to feel as though I planned this, but on this live stream, there are many times when I talk and you don't get to hear me, or you don't hear every piece of what I say, right? That's because this application is communicating over a UDP layer, right? So this application is built over a UDP layer, and it's decidedly so. The reason is because the data I'm sending to you, right, is we need that data. You need that data in real time. All right. So as I'm speaking to my microphone, that what I'm saying has to get to you in real time. Okay. So because of that, all of those protocols that enforces proper data transfer, right, are not observed on UDP. Okay. So with TCP, those rules are really enforced. So if I'm sending data from one end to another end, every piece of data has to be transferred. Is that clear to everybody? Is that clear to everybody?
Yes.
All right. 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 Now on the application layer, yes, this is the layer that you will most often be using. So you have HTTP, you have HTTPS. Both of these mean the same thing. The only difference is that HTTP, the data you're sending is not encrypted, right? So on HTTP sits on top of TCP. HTTPS also sits on top of TCP. Now the idea is that both of these they have the same functionality. It's just that one has an encrypted way of doing things. So if I'm sending data to you, all right, over HTTP, anybody who sniffs on that network, right? Anybody, a hacker who is just there, can intercept that request, all right, and then see what data I am sending to you. There's a way I used to do it here. It's just that I don't have those tools anymore. But there's a way I used to do it on my Linux machine, where if I have two devices connect to my computer, right, I could use my computer as a sniffing tool, right, to sniff the network, especially if I know that the data is not encrypted. They're not communicating over HTTPS. But that's bad practice. Don't do it. Don't do it. I mean, you can be sued if you do that. I used to, yeah. So how I even got to know about it was I read an article one time where folks in the office, they could sniff on people's network or sniff on the network and see the computers who were talking to each other, see the messages that were sent. So you know how in a regular office, everybody would be will be connected to the same to the office network. Devices on that network can, when messages are sent over HTTP, those messages are not encrypted. Anybody who is sniffing can actually see. You could, I mean, see people who are crushing on each other, people who are lovers in the office, and see what messages they are sending. I mean, that's how bosses used to, see what their staffs are doing. Okay, so that was what made me curious about it. But of course, that's just how it works. Ensures encryption. Now, WebSocket, the way it works is that it's built on top of HTTP and HTTPS. But the idea is that WebSockets allow um, transfer of data, all right, between two parties in a way that does not. So, okay, so I guess I have to put it this way. So, the background is that with HTTP, if two computers are sending data, there's this protocol where the client has to send a request first, and the server has to acknowledge that request, and then the server, the client, this is so it's a three-way thing now. You have the client, you have the server. Okay, so the client first of all makes a request to the server. The server acknowledges that request, okay, and then tells the client that, look, yes, I've acknowledged the request, okay, and then the server also sends like an appreciation. That's the best way to put it. The client sends an appreciation to the server to say, oh yeah, thank you for acknowledging my request, and then data is transferred between them. And then after that, that connection is closed. So how I can explain that is if I go to github.com, picture this as me being the client trying to access this web page. Can you all see my screen?
Yes, yes.
Okay. So this is the web page. Now I have this address and then I access github.com. I am the client and trying to access this data on this page. What goes on behind the scenes is that before this gets to GitHub servers, I send a connection request. GitHub server acknowledges the request and sends me back this response. And then I send an acknowledgement that, yes, thank you. I have gotten the data I requested from you, and that connection dies. I don't get notifications. I don't get anything else apart from this particular piece of data. But WebSocket is a bit different. So if I send a request, okay, and then you acknowledge it as the server, and I acknowledge that, yes, you acknowledged my request, all right, by sending me the data. The connection does not immediately die, but the connection lingers, okay? So now what the essence of that is that we can both continue to send data across, okay? So even after we have done the three-way acknowledgement, so the client has sent information to the server has acknowledged, and the client has also acknowledged that the data has been transferred. The connection doesn't die off, and we both can still continue to send data. All right. So the request response cycle for WebSockets doesn't die off after the three-way communication. Okay. So, or the three-way handshake, as they like to call it. Right. So, of course, this is evident in chatting applications. Right. When you open your Facebook Messenger or your WhatsApp, all right, when data is sent from one party to another, right, the person who is on the receiving end can still send you information, send you back a message in real time, and you see it. All right. It is used mostly when people are building chatting applications, when people are building video games, or just gaming applications, anything that requires real-time connection. Okay. And I know some of you want to ask, is it also used here? Yes, it is. Okay, so if you see on the chatting here, you have the chat, right? I can send data to and fro. Okay, here the WebSocket is what powers this. Okay, so as soon as the connection is established, it doesn't die off. It lingers until we explicitly close the connection. Okay, so that's about it. So I've explained what an IP address is. It's like your home address for a device on the network. It allows computers to connect and communicate with each other. You have the IP4 and you have the IP6. The IP4 is 32 bits. The IP6 is, I think, 1, 2 bits. The number escapes me, but then that's what it is. The idea behind IP4 is that that was the first standard, but IP6 came along because they figured that computers were being created every day and numbers were not just enough to go around all of the computers. So they devised a new means to give a unique identity to every computer connected to the internet. Okay. Port numbers. All right. So port numbers, how I like you to think about port numbers is think of it like a country, right? So just a simple concept to wrap everything outside. So think of your computer like a country, right? So I'm using that just to draw parallels to the fact that every country or countries that are close to the water, right? That are close to seas and oceans. Those countries usually have ports, right? So Nigeria, for instance, has a seaport. Uh, it has the Fibom seaport. It has the Cross River seaport. It has Lagos seaport. Now, if I live in, or if for Lade that lives in London, if she wants to send something to me here in Nigeria, something that is heavy, something that she cannot transfer over the aeroplane, she would send it via the ship, all right, and it will get to me via my port, right? Or sorry, via the ports in my country. So like Lagos, she will most likely send it to Lagos Seaport, and I will go get it there. Okay. I don't know the protocol, but that's just the idea. So your computer is like a country. It has an IP address, just like your country has a name. Okay. And then you have ports. Okay. So your computer has a port as well as an IP address. The IP address is what identifies your computer on the internet. And the port is the channel that allows data to enter your computer, all right, that exposes the application or the process, all right, on your computer that you want people to request resources from. Okay.
Back in the days, my mom would bring food back for us.
Does that analogy make sense to everybody?
Yep.
Right.
Yes, it does.
So, yes. So, your port is the outlet that your computer allows for every computer for clients to access resources from your computer. That's just the idea. So a port is a logical construct that helps direct incoming network traffic to the correct application or process on the machine. When a client, a browser, makes a request to the server, the request is directed to a specific port number. The server listens on that port, and the application handling the request processes it. Okay, so now I remember our example here where I said we have an IP address. This is my IP address. Okay, where is it? Yeah, this is my IP address on the network. This is the IP address on my local host. So what that means is that with this IP address, if I have processes running on my machine and I want to have them talk to each other, I can use this, all right, to talk to it. All right. So with this, yeah, I wish I could see the port number of this is Google. I'm sorry, GitHub. I wish I could see the port number of this IP address, but sadly, they don't expose that to you. All right. As a backend developer, it's also something you want to do. So most of all your applications would surely run on a port number, but it is not advisable to expose that port number to the public. Okay. Of course, you can see there are some sites that you cannot access directly using the IP address because it's just not safe. Okay. So what they like to do is mask the IP address and the port number over something like a domain name. So like this, you have www.github.com. Is for one, it's easy to remember. Secondly, it hides the IP address and the port number. So while you have this, behind the scenes, there's an IP address and a port number responsible for exposing the resources that live on this computer to you. Okay, so that's just something I want to let you know with this. So web servers like Nginx or Apache listen on port 80 or 443. Now, I wish I could show that to you. Of course, I'm going to show that to you. Let me go to my. I think I do have. Okay. Oh, sorry. That would be for my application. But Nginx or Apache. Now, these two are actually web servers. All right. So these two are web servers. They are, like I said, they are applications that live on my computer. Okay. And for me to access a resource that lives on my computer, I would have to access it using this as a port number, using this port number. All right. So this port number actually identifies the Nginx or Apache. All right, as applications that live on my computer. Again, let me explain. I have a computer, the server, it has an IP address. Okay. Port numbers are outlets, like I said, allow for certain resources to be exposed. So my computer, for instance, has MySQL as a server running on this machine. Now, I'm trying not to confuse you with the semantics. So I know many of you are confused when I say server and computer and this. The idea is this, right? My computer is a server, but then applications that run on my computers are their processes, and each of them have a port number that also identifies them. So think of it again, back to our example of a country. You have Lagos or you have Nigeria as a country. Nigeria has different ports. So it has Lagos, it has Akwa Ibom. Each of them are unique. All right, each of those ports are unique. So if I'm sending data to, if I'm trying to access something from Akwa Ibom Seaport, all right, it would not be the same as what I'm trying to access in Lagos Seaport. Both of them are different. So while my computer has an IP address, right, it also exposes different ports that expose different resources. So I could be trying to access Google or trying, there's something, okay. I could be trying to access Google's web server, right? But then Google has many services. It has YouTube, it has google.com, it has Google Docs. Let's just imagine that all of those are applications that run on the same server. Each of those applications are going to have a port that exposes them. And Google Docs could run on port 80. YouTube could run on port 500. Which other service do they have? Gmail could run on port 30. While each of them share the same IP address, okay, they all run on different ports, okay, and those ports help identify the resources. They are like a marker for the kind of resources that you can access from that server. Does that make sense to everybody?
Video does it.
Hello, does that make sense to everybody?
Please, can you go over that again?
Okay, so I'm saying that your computer is a server, okay? Now, on your server, you can have many applications running on your server. So you could have your Node.js application running on your server. You could have a Python application running on your computer as a server. Now, each of those, another computer is trying to access the resources from your Python application running on your server. That client would have to know the port number, all right? Just as much as he knows the IP address, he also has to know the port number of the application or the resource it is trying to the resource is trying to get. So if I have a Python app, okay, running on port 3000, and I have my database app running on port 3006, all right. If an external computer is trying to access data on the application running on port 3006, all right, by requesting data over the same IP address, it shouldn't get the application or get the data running on port 3000 because it is actually requesting the resource on port 3006. So again, back to the country analogy. You have a country, the country it exposes different ports to you. If you request a resource, if you're requesting something from the port in Lagos, right, you shouldn't get the same thing um, as though you requested data from a different port. So Lagos, you request, let's say Lagos has rice and beans. That's what Lagos Port likes to give. And then Port Harcourt, if you go there, you get fish. So if you're making a request to Nigeria as a country that houses all of those ports, you have to be explicit about the port you're requesting from. So if you're requesting from Lagos Port, of course, you should know what to get, rice and beans. If you're requesting from Port Harcourt Port, you should know what you get. So same thing applies here. While you know the IP address, you also have to know the port you're requesting from, because the port is what gives a marker or an identifier to the resource you're requesting. Now, all of this may be unclear to you. I'm going to show you an example before I close for the day. Another crucial thing too, you also have to know is databases, because this is where most of your resources are stored. So most of the applications you come across, most of them are stored in databases. Google has a database. For those as you progress in your journey as a backend engineer, you would stumble on system engineering content. All right, system engineering is actually a field on its own, and there you would learn about how to architect your application. So you would learn about what databases are well suited for the kind of applications you want to build. So if you're building an application that would require a lot of write, more than read. By write, I mean storing data. All right. You would want to use things like MongoDB. Okay. So if you're, it depends, right? If you have an application that does more reads than writes, you want to use things like Redis. All of those are databases. Okay. Now, the idea is that data, as a backend developer, you would use databases a lot. So it's just crucial that I make you aware of that. Databases store and manage data efficiently. As a backend dev, choosing the right type of database is crucial for performance, scalability, and maintainability. So they are most often grouped into two. These are the two prominent categories you would find: relational databases and no relational databases. The idea is that with relational databases, your data is in a specific schema. Okay, so you don't now. I wish I could explain what a schema is, but the schema is a structure, is a rule, all right, that defines a database structure. Okay, now all of those are just semantics. It will not make sense to you if you don't see it in practice. But again, as we progress in our journey, you're going to figure it out. I'm going to explain more of that to you. With NoSQL databases, the schema is flexible. So you could have a table, right, that has 10 fields, and then not the same table, you find a row that has 4 fields. Okay. That's just the difference between NoSQL databases and relational databases. With relational databases, the schema is very solid. It doesn't break. With NoSQL databases, the schema is flexible. You can adjust it anyhow you like. Okay, you can have a table that has 20 columns, and then you have a row that does not fill all of those 20 columns. You can have it fill maybe just 10. Okay, and you can have another row that takes up 21 columns. It's just so flexible, and it came out recently. It's not very back in the day, relational databases used to rule the space, software engineering space, but this just came out recently, and it's even though it's not that dominant yet, it's not is used, but then it doesn't stand when you compare relational databases to it. Relational databases are used more often, but then it's still something that you come across as a backend developer. So now the real question is, as a backend developer, who are you? A backend engineer is a software developer responsible for building, optimizing, and maintaining server-side logic of application. They ensure that the data is processed efficiently. APIs are functional. I'll explain what that. Okay, I think I gave you an analogy. And applications remain scalable and secure. Your job, basically, as a backend developer, is writing the logic that holds an application. Now, in case you're wondering what logic is, if your application is supposed, let's say you build an application that is supposed to send money to students who have, or send money to users who have a particular ranking. Okay, so let's say you're building an application, a gaming application, where as a user progresses through the ranks, when they get to a certain level, they get to receive some rewards. That's a logic. That's the logic that defines your application. So that logic would be handled on the server. You as the backend developer would be the one to write that logic. Okay. So that's just basically what you do. Now, the front end would be the one to show, the front end developer rather would be the one to show or to provide an interface where you can use the process of that logic that is written on the backend. Okay, so that's just the idea. So a backend developer is the one responsible for maintaining server-side logic, writing the server-side logic, and managing everything that goes on that end. Okay, so the core responsibilities of the backend engineer, your job is to build APIs. You create endpoints for front-end and mobile apps. I'll explain what that is shortly. You would design databases. Now, this is actually a big thing in and of itself. Designing your database schemas, all right? Because when you're confronted with an application, all right, or a problem, all right, you first of all have to think about the structures where the data is going to be stored, how you're going to retrieve that data and provide it back to whoever needs it. That's something you have to figure out, and all of that comes under this category. Okay. You have server logic and business rules. This is something that you would have to implement as a backend developer. You also have to implement authentication and security. So your applications, you have to ensure that they are secure. One of the things you would like to do is use HTTPS over HTTP. So you want to ensure that your application's data is sent over HTTPS. Now I'm just saying that that one just jumps out at me because that's like one of the things you have to ensure as a backend dev. There are many other security practices, performance optimization. You have to ensure that your application has low latency. What that means is that if your server is trying to send data, all right, that data shouldn't take too long for a request. It shouldn't take too long to send the data actually. So if a request comes to a server, it shouldn't take too long for the server to process that request and send back a response. Okay, so you have to ensure fast response times. There are ways to manage that. And maybe I could even do anyway. Networking infrastructure, you would also have to be responsible for managing the networking flow. So there's a concept called reverse proxying. The idea is that you have a computer act as a proxy to backend server. So you have one computer. It's more like a door, right? So when request comes to the server, this proxy, okay, takes the request and distributes the traffic to many other workers. Now, this will make sense to you as you start. Okay, so what's an API? An API is a set of rules that allow software applications to communicate with each other. It defines how requests and responses should be structured so that the system can exchange data efficiently. That's just what it means in simple terms. Okay, so this is an analogy to explain what it is. As a front-end developer, as a front-end, You place an order to the menu. The API takes your request. The API is the waiter that takes your request to the kitchen where you actually prepare it. Now, of course, your kitchen is what your server, your backend server, okay? And then this API is also what delivers back the response to you, the front end who placed menu or placed the order, okay? So you have there are types of APIs. You have REST APIs. So these use HTTP methods. You had seen it. You had seen it as during in the networking session. So you have the HTTP, HTTPS. Each of those ship out this method, right, to allow you request resources from the server and also get responses. So the get, all right, just means getting resources from a server. The post here just means sending data to the server to store. The put means updating, all right, and then the delete means deleting whatever resource you want to be deleted from the server. Data is exchanged in JSON format. Now, what this means, this is just the format where it's a standard format for data transfer. Okay, so think of it like a language, right, that allows data transfer between a client and server. There are many other ones. There's protocol buffers. So for people who use microservices, where you have two servers communicate with each other, for some of them who want to be very sophisticated, they don't use JSON, they use protocol buffers. Now that one works differently, but then it ensures low latency. So since you have the data transferred in raw binary in zeros and ones, it's usually faster, but this is very widely used. Okay. And then you have GraphQL. Okay. It allows clients to request only needed data. That's just the only thing that makes this one stand out. WebSocket APIs, I'd explain what this is. So this one works differently. After your three-way handshake, it maintains the connection to allow steady exchange of data without closing and starting. Okay. Is that clear to everybody? Am I still on?
Yes.
Okay. Now, project time. So we would build a sample Hello World application. For those of you okay. For those of you still with us, we're going to build an application. I don't know if you have Node.js installed on your machine, but I do. So here, this is where I'm going to explain all of those things. All those things I said about port numbers and IP addresses. We're going to see all of them demonstrated here. So this is my Node.js application. I think I should start this from scratch so everybody gets to see. So I'm going to start here. I'm going to create a new project, a new folder. For those of you who attended the front-end masterclass, I remember the instructor there saying that you most likely want to start a new project by creating a new folder. So yeah, that's exactly what I'm going to do. So I'm going to call this studio. Okay, let me just call this Hello World. Okay. Yeah. So given that, I'm just going to open a new. Can you all still see my screen?
Yes, we
Yes,
can.
Okay, fantastic. So yes, I trust the authors. Now, here's what I did. I opened the VS Code is actually a coding editor. Okay, so it's more like your Microsoft Word, right? So it just provides you that interface to write your application code. Okay, so I'm going to call this. No, I don't want to create a folder. I want to create a file. Okay, so I'll come here and I'll call this index.js. Or you know what? I'll call this index.500. I don't know if that's possible. .js. Okay, that's that. I'm going to call this index.3000.js. You would see why I'm doing this in a bit. So as a backend dev, right, another thing to consider is you would also have to pick the stacks that you want to use. So by stacks, I mean the programming language. So I use JavaScript mostly, Node.js, but you could do the same thing in PHP. You could do the same thing in Python. I think recently I started using Python. And even though it's a bit strange, but processes are still the same. That's why I'm able to use it. So as a backend developer, trust me, uh, you would have to be switching stacks. Okay, so it's not every time a problem or job comes to you that will require you using the stack you're comfortable with. Okay, there are times when you have to use a stack different from yours and you have to pick it up very quickly. Okay, so yeah, I'm going to show you, teach you the mindset you need to have to be able to pick up stacks as quickly as possible and use them, because again, the processes are the same. So it's like people who design with Canva and people who design with CorelDRAW. Okay, both of them are designing. They're solving the same problem, but it's just that they're using different tools to solve the problem. Okay, so I use JavaScript, Node.js. You, I don't, but that's just what it is. So I'm going to install some dependencies. First off, I have to initialize the. So what this means is initializing. I'm trying to initialize the application. I'm trying to make this a backend. This is just a requirement of my runtime. I don't need to explain much of this to you. As we progress, you will, but for lack of time, I'm just going to do all of this and install the package. So just to make this possible. Now I have that installed. I'm going to install a dependency that's going to allow me run this as a server. npm install express. I think that's about it. If I had known, I should have just copied this. But anyways, same thing. I should have express. So why? Okay, still loading. Okay, just a second. Yes, it is done. So you can see the express package is available now. Okay, so I'm going to go ahead and require. Okay, so require express. Okay, now much of this will not make sense to you, but this I'm quickly going to show you the parts that pertains to you. So remember, I had said something about get as a method. Just a second. Okay. So I had said something about get. Okay. Get is a method that allows you access resources that live on a server. Okay, so we are going to use that method here. So I have app.get. Okay, and then now the thing I said about API, this is it coming to play. So with this, okay, that this is an API route. This is that waiter in the kitchen or that waiter in the restaurant that takes your request to the server. Okay. Now, this is one. Now, this is your request. So, okay. And this is your response. Okay. So now I'm going to say rest.status 200. Now, what this means is this is just the status code. The idea behind the status code is it's just a way to confirm that the request is successful. So when you request data from the server, you should get a status code. Every response you get back from the server usually contains a status code. So for 200, it just confirms that the server actually has responded with the required data that you requested. Okay. So now I'm going to say message. Now, hello world. Okay. Now, after having done that, this is the API route that takes your request. So this is going to listen for every request that visits this route. Okay. And then it's going to send back. So every time somebody visits this route, with a get request, okay, the server, okay, is going to respond to this using this particular route. Is going to respond on this route with this message, hello world. So I'm going to say hello world from port 3000. Okay. Now, after having done that, I'm going to listen. Now, I'm going to listen on that port. So I'm going to say something like, okay. Now, why is this important? Remember, I had said something about port IP addresses. Okay. Now, my computer has a unique IP address, and because I'm running a backend server, I'm running a backend application. It's an application that lives on a server with a unique IP address. But since I want to expose this application with the resources that it contains, I also have to expose it with a port. Does that make sense? So I'm exposing port 3000. Okay. So that's the case for this. So if I go ahead and use the runtime to run this, I should get back. So I said, what's the name of the file? 3000.js. So I have this application running on this port. So you see the server is running on port 3000. And now if I go ahead to my browser, so say I had this application running on my computer and I provided you the IP address. I think I should even use this raw IP address here. Okay, so I said this is the IP address. Oh, let me do that. This can be funny sometimes. Okay, so I'm going to copy the IP address and I would paste it here and give it a port of 3000. Now, you see the IP address. Here's what happened. This is the IP address. All right. The first bit, so 32 bits. So it's the first 8 bit. 8 bit is 1 byte. Okay. So the first byte, the second byte, the third, and the fourth, all of that making 32 bits. So after doing that, I specified the port that this was running on, as you can see from my application. So this is port 3000. The server is listening on this port. And now, since I am visiting this route, okay. Now, this is the route I'm visiting. Of course, you can see I'm appending that here, okay. What resource am I sending back? I'm sending back hello world from port 3000. So if I go ahead and run that, I should get this message, hello world. Okay. Now, I'm going to do something similar here. So I'm going to have this same application run on port 5000. I'm going to just copy and paste same logic. It's just that I'm going to change this to port 5000 and not 3000. Okay. So, now this is already running on port 3000. I'm not going to change it. I'm just going to leave it there. Port 5000 now. Okay. So I have node. This time around, I'm going to say index.5000. Okay. Now, again, don't worry about all of these things. I'm going to explain them to you during the course of the program. Just know that this is what you need to get the application running. Okay, so this is port 3000. Okay, oh, sorry. Okay, guess what? I think I should just leave it here and try to start the application. Who can see what's happening? So I have port 3000 and I'm trying to start this application on port 3000. Okay, let's see what happens. Okay. Now, okay. Oh. Okay, so port 5000. Right? Yeah, so now I have both of them running. So I have port 3000 and port 5000. Now, if I try to access this particular resource, okay, so if I go to port 3000, using the IP address of 127 port 5000, what do you think I'd get? Hello world from port 5000. Okay, now if I change the port to port 3000, I'm going to get hello world from port 3000. Now, just another thing too, if I change this to welcome, remember I had said this is the API. Okay, so this is the API route. Now, if I go ahead and I'll have to restart the server again to effect those changes. So if I go ahead to visit this port, okay, so I think the cache is still the cache is still storing that as a response. I don't know if I did that. AF port 5000, that's why I did it on. Okay, so if I try to visit that again, I don't know if my cache is still very active. Now, here's what I'm getting. I cannot get this. And the reason why I cannot get the resource there is because I changed this to welcome. Okay, so there's nothing on this server that listens on the slash, that listens on this. Okay, so for me to effect that, for me to get the data that I want to get, I have to use the welcome. Okay, and if I do that, I get hello world from port 3000. So this is how everything comes to play. There's an IP address, like I earlier explained, and a port number. Okay, so the port number is what uniquely identifies the resource on the server I'm trying to access. Now I am trying to access from port 5000 this time, and by specifying the port, I'm getting the data that pertains to that port. If I must get data from port 3000, I have to specify the data or specify the port number I want to request that data from. So again, tying it back to our concept of country and port numbers as the seaports that exist in those countries. If I'm in Jamaica and I want to get a resource from Port Lagos, okay, from Nigeria as a country that has different ports. So this time I'm trying to request a resource from Port Lagos. I'll just call it that. And so Port Lagos serves, let's say, rice and beans, right? So if I try to access that resource from Port Lagos, I'm sure to get rice and beans. If I try to access the resource from Port Lagos and I get beans and yam or fish and potato, there will be a problem. Okay, of course I won't even be able to get it. So I guess that explains the concept. So the IP address is the unique identifier. The port number is the unique identifier for the application or your backend server. So in this case, like me, I have two backend servers. So I have this one running on port 5000, and I also have this one running on port 3000. Of course, I could even spin up another one. I could copy another one, and let's see. Let me do something again. So I could say, I could call it anything. So I could say welcome.js. This time I'm just going to say this runs on port 3001. I'm going to have it listen on port 3001. Okay, 3001. And then here I'll say hello world. This is the message I want to send. So anytime somebody visits, they should get this. So if I go ahead to run welcome.js, I have this port running on 3001. And when I'm visiting this, if I change this to 3001, let me confirm if I have that response there. Okay, so this is port 3001 now. So if I hit the welcome button, you can see hello world from port 3001. So different applications running on the same server and on different ports. And because I'm accessing the same computer that houses each of these applications, all of them have the same IP address, however, different ports. Does that make sense to everybody?
Yes.
Hello? Does that make sense to everybody?
Yes, it does. We can hear you.
Okay. Does anybody have a question? Does anyone have a question? Oyewole, Harrison, all of everybody. Does anybody have a question? Say again. Okay. Oh, yeah, I can see. Yeah, please go ahead. Spill your question. HTB, your question. Yes.
Question.
Yeah. Okay.
My question is, how can we run this stuff on a remote server?
Yes, you can definitely
hear me?
run. Yes, I can hear you. Yes, so can you hear me?
How can we run it on a remote server instead of running it on our computer?
Yes, I would answer that. So they are cloud service providers. So I don't know if you've come across AWS, GCP, Google Cloud, Microsoft Azure. All right. What those companies do is that they provide you services, they provide you cloud services. So the idea is that this application that lives here, okay, is taken and then hosted on their computer. So they provide you a computer that has a unique IP address, okay, and then what that does is that it allows you host this your application there, okay. So with that, they provide you an IP address. Remember, I said that, and with that IP address, anybody can connect to it. So I don't know. I wish I could show you this. But it's just against. It's bad practice. I'm not supposed to show you this, but there are servers that I connect to. Okay, I'll just do my best. So this is a server. Okay, you can see this is a server I'm connected to, right? This is another computer that houses an application that I'm currently managing. Okay, you can see AWS. Okay, so AWS provides me a computer where I can host any application I am building. Okay, so if I build my application, I can host it here and run it live. And they provide me an IP address. I'm trying to hide the IP address so you don't see it. All right, so they provide me an IP address I could use to connect to the computer, to connect to the application I am building. And of course, this application also uh, runs on a port. So I have a port assigned to this server assigned to this application, the application that I have running on this server. So I have a port assigned to the application that allows me connect to that application from wherever. Okay, so that's the idea. Does that answer your question? HTTP. Have I answered your question? Hello, have I answered your question? HTTP.
Yes, sir. Yes, sir.
Okay. Any other question?
I have another question, sir.
Okay, go ahead. Go ahead.
Okay, let's assume you build a basic login page.
Yeah.
So how can you connect like a backend that display another page entirely as a response to sending inputting a detail into that login page, and it will reply you with a kind of like a page instead of sending you a message like this is port something, it will reply you with page.
Fantastic, fantastic. Now, there are many layers involved. So when you have a page, an application, I like to call it an application. That in itself it runs on a port. So you have your front end. That's a front end app that you're describing. The front end app provides you a login form. Okay, and then you can type in the user's email or password or whatever you want to put in there. And then when you click on submit, okay, you are taking that data, okay, that the user has imputed to another server. Okay, you could also keep it on your server, but most of the time you're taking it to another server, another computer that has an IP address and a port number. Do you get? So that computer would, when you do that, you would most of the time define a route like this. So you define something like this. Okay, so you could say maybe a welcome. Okay, and then uh you would say something like maybe you could define it with anything. Okay, and so when that request comes to this point, okay, this is going to respond back. This RS just means response. I think I should hover on it. You can see response. This is going to respond back with that data that you have sent. Okay, I don't know if I could please spin up something, but for lack of time, okay, I'd have shown you how your requests get to me in the server. So if I have this on the server, what is going to happen is that data you're sending is going to come to the server as a request. It's going to come in the body, okay, of this request. And I can take that data and do whatever I like with it. So I could take the data and store it in the database. I could take the data and add +2 to that data. I'm just saying, I could take the data and just basically anything that I would use the data as it pertains to the application logic. Does that make sense?
So Yes, sir.
Okay, okay. So this is just the intro. As we proceed, you will get to see all of these things, get a solid feel for how they work. Okay. Right. So, any more questions? Any more questions?
HTTP rather, do you still have more questions? Your hand is still up.
Okay.
Sure.
Somebody wants to say something. Okay, okay. So, in the absence of any other question, I think this is where we wrap it up. So, yeah, I hope you all learned something. Just to go over everything, your flight. So we started with what a server is. A server is a computer, and every computer has an IP address, and the IP address um, houses different ports where different applications live on. Okay, so I can have one application, a database application. I can have an application that only says hello, welcome. All of them will be on different ports. Okay, and then the API is the route that defines the roadmap to the application. Okay, so uh, that's just what it is. So a server is basically a computer with networking capabilities. If a computer does not have networking capabilities, you will not be able to access data from it. Okay, and then a client is just whoever is requesting resources from the server, from the application, or whatever you like to call it. But just basically the device that's requesting data or resources from the server. Okay, so there are types of servers, web browsers, mobile apps, desktop applications. Networking, of course, like I said, is very crucial. You need to know what it is. There are many ways to access, many ways you can access resources from the server. So you could connect over Bluetooth, you could connect over cables, routers, and switches. Uh, the networking layers, you have the MAC address, the unique address for every computer, the internet, the IP address is the one that identifies, that is a unique identity for every computer on the internet. So MAC address is standard, it's static, it doesn't change. All right, it's just the computer's, you could call it the computer's uh, name. The IP address is a unique identity assigned to every computer on the internet. And then the TCP layer, what it does is that it allows steady transmission of data. When you send data, every bit of it has to be sent, right? UDP, it doesn't have any of those rules enforced. Yeah, but I've explained what that is. Databases, they're very crucial. Where you store your data is really important that you
I have a
understand how.
question.
I think in our next class, that's what we're looking at how.
Someone is asking what's the difference between authentication and backend. I think it's lost. I just need to maybe in the next class, it would give you answer.
Okay, does anybody have a question? Sorry, I'm available to take.
Yes, somebody asked what's the difference between authentication and backend.
Authentication and backend.
Yes.
Okay, so authentication just basically means a protocol that ensures that you identify who is accessing the resources on your server. So if user A is trying to access the resource on my server, right? Authentication is just a means by which I can tell who that user is. So if I don't like the user who's trying to access the resource of my server, I can block him, bounce him off. That's just what it is. So the server is where the data live, where the resources live. And authentication is just I can protect whoever is trying to access those resources. Does that answer the question? Whoever asked that, I don't know if that works. Is it clear?
Yes,
Okay.
Okay. Thank you very much, Ezekiel, and thank you very much, HTB, for asking that question. I put up a poll for people just to get feedback, and some persons already interacted with it. But this is another quick check-in. I mean, if you've been part of the classes from the very beginning, you should be able to answer this one. I mean, even if you came halfway, it's a pretty chilled question. Just a quick check-in. I'm sure it will pop up on your screen. It's a very simple question where I'll try to get the okay, launched. What does a backend developer primarily work with? I mean, a very simple question. I think everybody on this call should be able to answer by now. You should see the poll on your screen. Question is, what does a backend developer primarily work with? Some people are already interacting with it. So yes, thank you very much, Ezekiel. I mean, this was a very, very deep We did first the theoretical aspect, and now we did the practical aspect, and this is very, very much introductory part. And hopefully on the next class, we'll be happy to see every other person that joined us here. Also get ready for the next class. And I'm sure there are some persons who joined from maybe other communities. Maybe you just saw the link up and maybe a friend or anybody posted and you just joined. And it's very important for you to know that doesn't end here. We have a masterclass WhatsApp community where every other person is interacting with everybody depending on the track that you are in. I mean, there are other persons who are also into product management, front-end development, and also data analytics, still in the same group. So you could, I put up on the charts, I'm not sure if everybody can see it, but let me copy it and paste again. There's a very, very simple link that you just fill. That if you're not already part of the community, all you just have to do is fill up that masterclass registration. And at the end of the form, to pop up a link for you to join the WhatsApp community. Everybody's already engaging on the quick check-in question, and everybody's picking the right answer. Ezekiel, are you seeing the question?
Yeah, I can see the quick check-in question. What does the backend developer primarily work with?
Oh, okay, cool. And you see, I see the options here. I mean, nobody has anything else aside server-side logic and database.
Yeah, I can see. Yes, of course. So the class was enlightening, I like to think.
Okay. Yeah, that's very good. And I mean, thank you very much. HTB, yeah, you said you joined late. You joined from GDG Learning Community or GDG Learning Chapter. Thank you for joining in. Just fill up the link on the charts, the ones that say tinyurl/studio3 masterclass 1. It's a very simple form. Just fill it up and you get a link to join the community, join others there. I mean, we have a pretty much engaging community on that end. And another person who's also in HTB's scenario or phase, whatever, just feel free to also fill up the form. And also, there's an attendance form. This is a very, very serious masterclass because we're tracking everybody. So the attendance has been posted by patients. Let me copy that and paste again. The attendance is for us to track every who is attending the classes because we're keeping up a leaderboard, especially for those who are already on the community. Because at the end of the day, you would want to know how you are doing here. So, and there are basically, I would say, rewards or incentives in terms of participation. Do you want to share the task here or it will be on the WhatsApp group?
Yeah, on the WhatsApp group.
All right, that's fine. So every other person, please expect the task for this particular session on the WhatsApp group. And that will be shared. I mean, I'll do that on the announcement and also share it on the WhatsApp on the masterclass group. So please, there will be submissions dates, and the form for submission will also be pasted in due time. Please engage with it and feel free to ask questions in anywhere, anytime you have any concerns or questions or any inquiry that you want to make. I mean, I still remain Imam, and I'm very, very sure we're going to be doing this again. With just check your calendar. For the new attendees or new joiners, you also please tag me on the group when you join, so I would set you up on how to see the calendar for all the other courses, all the other masterclass sessions. Thank you very much, everyone. And this is the final notes. Does anybody have any question before we close out? Any question, any inquiry? Thank you very much, Lade. Like just saying, thanks for the class. It was very insightful. We're happy that you enjoyed this class. Hello, Stanley, HTB, Harrison, Mubarak is sending hearts. Thank you very much. Precious, Shegun. No, sorry, this is not Shogun. I'm Akman. I can't call your first names on HCV. Thank you everyone for joining in and do enjoy the rest of the night. Thank you very much, Ezekiel. We can't wait to have the next session with you again. Thank you very much. Enjoy the rest of your night.
All right. Thank you, everyone. Good to be here.
Bye.
Bye.